Hello, and welcome to another online learning day for chemistry as we continue to learn more about the mole and how that fits into math and chemistry. Our essential question that you're going to work on today is what is something called Avogadro's number, and how is Avogadro's number related to 1 mole of any substance? So there's that mole thing comes back. Avogadro is our focus for today. All right, so go ahead and set up your focus notes. Our topic today is Avogadro's number and fill in the date that you're taking these notes. And then our 2 essential questions. What is Avogadro's number? And how is Avogadro's number related to moles? So then you've got a place for your questions and your summary that will answer these questions. And we're going to write down a few notes to answer these questions. What is Avogadro's number? And how is Avogadro's number related to moles? Go ahead and pause the video if you need more time to set up your notes. Otherwise, when you're ready to go, here we go together. Remember, you only need to write down the stuff in red. Anything else are just things that I want to talk about while we are learning about Avogadro's number. All right, so first of all, we got to know who this Amadeo Avogadro is. So Avogadro is his last name. Amadeo Avogadro was Italian, in the late 1700s. He was working in Italy. He was a lawyer for a while, but then was like, you know what? I want to be a professor of mathematical physics. So while he was getting that degree to be a professor of mathematical physics, he was doing a lot of experiments and research with gas particles. So like early 1800s, that's what he was doing. But the thing that's kind of weird and maybe a little sad about Amadeo Avogadro is that he didn't get any credit for his work because people were not even really believing that atoms were a real thing. It would be like if you opened up, like a newsreel or a newspaper or a magazine or a blog or something, and someone was talking a lot about unicorns as if they were real and all this research they had done, and you were like, oh, wait a second, unicorns aren't even a real thing. That is what Amadeo Avogadro was facing. People were reading his work and they were like, oh, wait a second, atoms, what's an atom? Like, that's not even a real thing. And it turns out that he died in, mid 1800s, 4 years before his work was accepted. So when he died, he was still trying to convince people. And there definitely were people that supported him. But the greater community did not fully accept his work, and he died thinking that there was a lot of people he couldn't convince about the really amazing stuff he had done. So from his work, we have something called Avogadro's hypothesis, and this is what it says. Equal volumes of gases at the same temperature and pressure will have the same number of molecules. Now, this is where Avogadro's number comes in. That number of molecules is 6.02 times 10 to the 23rd. That is Avogadro's number. So that's our first essential question. What is Avogadro's number? It is 6.02 times 10 to the 23rd. The volume happens to be 22.4 liters. We're going to learn more about that later. And the temperature and pressure are called standard temperature and pressure. And then the reason it's still thought of as a hypothesis is in honor of the fact that he died before it was really proven. So these, like this number and this volume and the standard temperature and pressure measurements, those were all of the things that were figured out after he passed away and was able then to convince the greater community that his work was accurate. But because he passed away thinking it was mostly a guess, based on fact and experimentation, it's still referred to as Avogadro's hypothesis. So this idea, 6.02 times 10 to the 23rd, that is equal to 1 mole. It's Avogadro's number, and then you can also see that 1 mole comes into play when we talk about volume also. We're going to learn more about this molar volume idea next time. For now, though, we're focusing on this, Avogadro's number. Now, because you know some stuff about moles and you know some stuff about Avogadro, I can ask you questions like this. Who is Amadeo Avogadro's favorite composer? Mozart. Okay, so I'm just being silly, but I do have some funny little chemistry jokes that I want to share with you. And then, where's Amadeo Avogadro's face carved? Where do we carve famous faces? In the United States. Mount Rushmore. All right, so these, of course, are just silly things. They're called mole jokes related to like the silly idea of Avogadro and moles. So just a little bit of fun with chemistry stuff. Okay, so then how does this fit into what we've been learning other than the fact that the word mole is in there? Well, Avogadro's number is only used for teeny tiny pieces because it is a huge number. This is what it would look like. If you were to write out Avogadro's number, this is what it looks like. It's huge. A little side note to kind of make you appreciate how big this number is. If you had 1 mole of marshmallows, like the normal size marshmallows that you might use for cooking or just eating or like making s'mores, 1 mole of marshmallows would cover the United States to a depth of 105,000 kilometers. So we would be buried in 6,500 miles deep all over the United States, that pile, 6,500 miles deep of marshmallows, if we had this number of marshmallows. That's how huge that number is. All right. This huge number is equal to 1 mole. And then remember, we know that 1 mole equals blank grams. That's molar mass from the periodic table. All right, so I gave it away. So that's molar mass. And so now if we have 1 mole, we know how many particles are present, even if that mass changes. So we could say 1 mole equals blank grams equals 6.02 times 10 to the 23rd. So we know how many little pieces are in there. And again, we could use this kind of like the idea of a dozen, right? 1 dozen would always equal 12. But the mass of those 12 things, 12 eggs would have a different mass than 12 feathers or 12 shoes, but it would all be 12 and it would all be 1 dozen. Well, 1 mole is always equal to this huge number, but the mass will change depending on what particles you're talking about. So that just gives some other connections about Avogadro's number and the mole and molar mass. All right. So it's really a new way to count things. So again, Avogadro's number is 1 mole equals 6.02 times 10 to the 23rd. But notice I haven't put any labels on it yet. So add this to your notes. The label on Avogadro's number changes depending on what you are measuring. So like this example I was giving before, 1 dozen is 12 eggs. It's always 12, or it could be 1 dozen equals 12 pencils or 12 tigers or whatever. It's always 12 and it's always 1 dozen. So it's always 1 mole and it's always 6.02 times 10 to the 23rd. But the label, it depends on what we're talking about. So let's learn how we fill that in. All right. So we have this already. So 1 mole is always 6.02 times 10 to the 23rd. But what is that label? All right. Well, if we're measuring elements, which are just atoms, they're just the tiniest pieces that we have that are whole things, atoms as the label. So if it's an element, atom will be the label. So we would say 1 mole equals 6.02 times 10 to the 23rd atoms of cadmium, because cadmium is just an element on the periodic table. So if you're dealing with an element, the label on Avogadro's number will be atoms. But notice it's still 1 mole and the number doesn't change, just the label does. Okay, well, what if it's time for another mole joke? Ready? Okay, where does Avogadro stay when he goes on vacation? Where would Avogadro stay? He would stay at a motel, or if he's feeling fancy, maybe a mole a day inn. Again, more silly little mole jokes. Hope you're having some fun with me with that. Okay, so back to the label on Avogadro's number. What if we don't have an element? What if we have an ionic compound? Well, remember, ionic compounds are when you have a metal element combined with non-metal elements. So metal plus non-metal compounds. We use formula unit as the label. And yes, the abbreviation is FU. You're allowed to say that when you're talking about formula units only. So again, it's still Avogadro's number. It's just a different label. So I might say 1 mole equals 6.02 times 10 to the 23rd FUs of sodium chloride, because sodium is a metal, chlorine is a nonmetal. So this is an ionic compound. And so we don't say atoms because this isn't an atom. And we don't just say compound because there's more than one kind of compound. So formula unit for ionic compounds. So again, it's always 1 mole. It's always Avogadro's number, that big, huge number. But the label has to match what you're actually dealing with. Okay? All right, time for another one. Are you ready? What kind of tests does Avogadro like? What would he like? Yeah, he likes multiple choice tests. That's his favorite. And what does Avogadro wear to the prom? Think about this one. Now, prom is kind of fancy, right? Like it's a fancy event for like high school students. So you get kind of dressed up. So what would Avogadro wear if he's going to get all dressed up? Formal attire. Again, silly, just little jokes related to the mole and then just using Avogadro's name. Okay. Last one. What if we don't have an ionic compound? What if we don't have an element? What if we have a covalent compound? That's when we have nonmetal elements bonded to nonmetal elements. That's the kind of compound we're dealing with, covalent compounds. Molecule is the label. So again, it's still Avogadro's number, but now the label has to match the chemical we're dealing with. So I might say 1 mole equals 6.02 times 10 to the 23rd molex, or molecules. So this is just the shortened version of molecule of water, because hydrogen and oxygen are both nonmetals. This is a covalent compound. So we can't call it an atom because this is not an atom or just an element. We can't call it an Fu because this is not an ionic compound. So again, the label changes to match the chemical, but the number is always the same. It's always 1 mole to match the definition of Avogadro's number. All right, how about one more of these? Ready? Okay, why did Avogadro throw out the bread from his refrigerator? Yeah, it was moldy. And what does Avogadro learn in math class? Yeah, he learns how to multiply and divide because they kind of go together. All right. So that brings us to the end of our notes for today to kind of introduce this thing called Avogadro's number. But because this is kind of hard to visualize or talk about because it's such a huge number, you're also going to do a lab activity today. So here's your to-do list. Notice that I didn't have you write any Costa questions during our notes because they were pretty short. So go back and write your Costa questions and your summary for today's notes. That gives you a chance to review and process and make sure today's information made sense. But then also there is the Avogadro number video lab activity. So there's a handout and then a video link to kind of get a better idea of what Avogadro's number looks like in a lab setting. Since it's such that huge number, it just is really hard to imagine or use. We're going to make it a little bit more user-friendly by doing that lab activity. And if you have any questions on this, just make sure you use my office hours. You could come today if you're doing this on the day it was assigned, or someday soon, just so you get the help that you deserve. All right. Thanks so much for learning more about chemistry. We'll see you next time. Bye.